Hello and welcome in fourth material of making an axe series. In this video we will create an axe assembly. So firstly create new document with empty name and then name this document by switching to A2 plus workbench with this additional workbench. The whole assembly will be in this workbench. So now it's necessary to create a name. I'm recording only the window so you cannot see the prompt of your operating system to create a name, but here you must apply sufficient name. For us this will be axe assembly with dash between. Click on enter and accept assembly 1 in such way. And now let's create new document. Let's switch to this document. You must use your A2 plus workbench, so A2 plus, and import shapes from an external file, and we must select the suitable file name in which you have all your shapes of axe. And now it's necessary to select everything related to axe construction. So these parts, and make them in such a way. So the axe is in such. I will shortly describe what is A2 plus workbench because I have not described this. So by usage of A2 plus, you have possibility to assemble whole part of something really complicated like complex system. In this way, we'll be utilizing this workbench for our project in making an axe. And the way in which A2 plus is working is select one surface and then select another surface, and you can use constraints. By these constraints you are making consistent shape. Consistent shape what means this shape isn't in opportunity to be dissolved to smaller pieces, so it acts like one connected by adhesive part. In this way we will use the connection. So you select first surface, then you must move around axis, and by holding a control key and selecting another part, you can see the allowed for this operation constraints. For us, these are 4 constraint operations. I will select coincident, and also here is a prompt that one part must be non-fixed. So not non-fixed, but set up as fixed. So set up this as true, and resolve constraints by clicking here, and you see the result of constraint binding. And now make point-to-point constraints. So click point-to-point, and you see that this is in one axis, so connected into point-to-point. The integrity of part you can check by clicking on element and moving this element, but it can move only when it's not set up as fixed. This is fixed, so the only part which can move here is this. It cannot move, so this part, by clicking this part and moving this, this part don't want to move from some reason. Or I check this another way, like this also, and solve constraints what brings this part to desired position. And it's nice, but I know also that One more point of constraint is here impedance. So again, move this part outside of desired point, select point, and select this point. Unselect. When you select it with holding a control key, keep in mind, unselect unnecessary surface, and you have 2 points to which you can apply a constraint, and here is a constraint, so accept. Next we are switching to another part, and one time more we will have same operation, but here also must be selected as fixed to true, and make same operation. You must select point separately. Here is config server, so you can use config server to solve your problems. And we see prompt when such problem occurs. Click yes to solve. And when the up bar buttons are selectable, this means the operation has been finished. So again, you have your shape here and this shape here. So one must be set up as true. This is a true. So select here and point to point. Again, one time more error occurs. Now we'll delay this manually. So I will change this, select this to true, and select this to false. And now let's try again. Now works. And move this part apart using your axis arrows. And one time more, as was in the top bottom part, use 2 anchor connection to always keep this side in position, point to point again. And now the last part to assembly is attach the blade, which is here really foremost. And you will use for this the firstly line constraint. So click this, hold control, move, control key, click, and select another line. You have to select it on green. Now use the axis coincident constraint. Error happened, so one from this part must be selected as fixed, or 2 are selected as fixed. So switch this fixed to here unselect, and here select as true, and refresh. Now is one in one desired axis. Now we'll use the point to point constraint, and here is a point. Select it here. You can change the size of points in view, but I won't do this here. Now select another point and select surface when unerringly, to be unerringly when you select this as a failure, and we see that the constraint is not available. This means the point symbol was lost. And another time point to point constraint, solve, and another time we can select one time more as was prior, and move here. Use your selection and select point, and switch to desired point, and another time use point-to-point constraint. Error have happened, so we will switch here and select here to true, refresh, other type of error, so true, here to false. Use your config finder, and we have here a constraint. We can check integrity of this part by moving this around axis, like here, and switch again to position. Now it's fully integrated, and we can check the correct position of everything, every part from wall assembled by moving this. Click on OK and refresh constraints. And when this bring back to position, means everything is nice fitted. Here is not. So here we have fixed to true, and we have here fixed to true. So one part like this must be set up to false, and again, and now come back. Now for this. So this is a test suite basically. Again, config finder. So another time this happen. This is selected as false. This is selected as true. So again to false, and this nicely fitted. And now move this part. Refresh, and everything is in position. So as we made this shape wally, you can also note that here is additional place to make a plate here, keeping this in one position more fine. And to stay with this, we must add this plate as a measurement here. So we will do this in another workbench, but firstly we must save this file. And saved is prepared by import, and we will import this as step. Sorry, this is export. We will export this as step type of file. So select your position in bottom bar. You cannot see my window because I'm using as I said, recording a frame in OBS. So select by save as the type of format, and this is step, S-T-A-P, step. I'm seeking this format. Step with colors, this is the name. And the extension is point step or point STP. So step, and select the directory to hold this file. Click save and export with unvisible objects, and select the unit is a millimeter. You can select meter or inch. Millimeter is the smallest. Click save, and now let's switch to your first assembly document, or in another time I will switch to create new, to present here for you, and we'll here import this exported one, click open. Oh, this is not this. Why? One thing more, check. Happens something weird. Import. Open. And it's importing only this. So I will suggest convert this to. This happened because I have selected one, and I must unselect everything and again click export by selecting everything what must be exported. So I missed this step, and after you have select everything, you must export this and click save and write onto and again import, and you have here your desired shape. Remove this unnecessary, and as you see this shape is here, you can transform this to move, and you see that this is everything in one suitable position. So here, as I said, it's necessary to create this plate. So firstly we will measure the distance between lines by switching to the body part design and attach here the measurement of distance, and here is the 0.35 meters, 0.404 micrometer, and the distance between these two is 24.25. Okay, so close this and create here a body, and in body you can reflect these surfaces by using a binder and using this tool as a binder also. And you have two types of binder, you can hide this, and you have 3D dimension. So now we can create a plate in this body and rename this body as plate. Create here sketch, and now let's create the origin shapes. So everything it here, and use your triangle. Here's constraint because it's wholly as green, and the thickness will be 0.35 millimeter as is on our measurement. So use after selecting a path when it's selected is on a green path tool, and now place here 0.35 millimeter, and you have your plate. And now it's necessary to save this file in your operating system file system as the axe plate. Keep in mind that you can create this operation in your basic axe assembly parts file by creating there a body and importing what you have made. And also you can create this project into your making axe basic project, but I have created in the different to show you that this is also possible. The variety of things are possible, and is saved. As you see, we can there bring here and bring to ourselves to A2 plus workbench and import from particular shapes by selecting a axe plate. I'm seeking I have here open and import just plate. Import, and we have plate here. Now we must place this plate in suitable position. So for me this position is for sure with axis parallelism for both sides. So we'll take as an example this part. And now let's make plane coincidence. So click here and click there one time more. And use plane coincident solve factor. And you see that here is a plate attached. So during manufacturing process, this file called a step will be interpreted suitable way, and the wall handle can be manufactured as one suitable object. So without divide to smaller pieces, which will be used to derive the construction. So this is the finish of whole series. So thank you for watching and see you in next series.